How cigarettes are made. From leaf to smoke, they are one of the most consumed and controversial products in human history. A stick of paper wrap tobacco, ignited in seconds and gone in minutes. But have you ever wondered how that cigarette ended up between someone's fingers? How does a leafy green plant from a distant field transform into a tightly packed roll of tobacco, wrapped in paper and sealed with a filter? The answer lies in a long and meticulous journey that begins in the soil and ends in the hands of a smoker. Welcome to the untold story of how cigarettes are made. Chapter 1. The tobacco plant. The journey of a cigarette doesn't start in a laboratory or on a production line. It starts in the soil. The tobacco plant, scientifically known as Nicotiana tabacum, is grown in more than 120 countries. What makes this plant so globally dominant? And why has it become the foundation for a multi-billion-dollar industry? Answer that. We must step into the fields of North Carolina, Brazil, China, or India, where rows of broad-leafed plants stretch toward the sun. Tiny tobacco seeds, barely visible to the naked eye, are germinated in carefully controlled nurseries. For 6 to 8 weeks, they're protected from the elements, fed nutrients, and given just the right amount of light and water. Once they're strong enough, they're transplanted into vast, open-air fields. From here, the plants grow quickly, developing the wide, waxy leaves that are the heart of tobacco production. But what happens next determines the very flavor, aroma, and burn quality of the final cigarette. After reaching maturity, leaves are harvested, sometimes leaf by leaf, and sometimes by cutting the entire stalk. What method is used depends on tradition, climate, and the desired end product. Then comes curing, a process that is both art and science. Is it better to dry the leaves in a barn or in the sun? Should heat be applied directly or indirectly? Air curing involves hanging leaves in barns for weeks, where they slowly dry in ambient air. Flue curing, often preferred for cigarette tobacco, involves indirect heat funneled through flues to accelerate the drying without burning the leaves. In contrast, sun curing exposes the leaves to open sunlight, bringing out different chemical notes. Each method brings a unique twist to the final product. By the end, the leaves transform from supple green to rich tones of golden brown. But the journey is far from over. Chapter 2. Grading and fermentation. Once the leaves are cured, they are far from uniform. They differ in size, texture, thickness, and even aroma. So how do cigarette makers ensure that every stick tastes the same? It begins with grading. Trained graders examine each leaf and classify them based on color, elasticity, texture, and scent. Why does one leaf make it into a premium cigarette while another is relegated to filler or scrap? The answer lies in millimeter-level scrutiny. But perhaps even more fascinating is the fermentation process. Fermentation isn't about aging for flavor like wine or cheese. It's a precise method of chemically transforming the leaf. Stacks of tobacco are piled high, where natural heat builds within the core. This triggers chemical reactions that reduce harshness, burn off excess ammonia, and deepen the tobacco's aroma. Can you imagine a stack of leaves heating itself from the inside out simply through biology and time? Depending on the manufacturer, fermentation can last weeks or even months. Some leaves are fermented multiple times to achieve just the right smoothness. Following this, the tobacco is stored in climate-controlled warehouses, sometimes for years, to further age and mellow. At this point, what started as a plant is now a carefully cultivated commodity. Each batch is like a vintage, with specific flavor notes and physical properties. Chapter 3. Primary processing. In the factory with the leaves cured, fermented, and aged, they're ready to enter the factory. But how do factories handle tons of delicate leaves without destroying them? The answer is primary processing. Tobacco arrives in massive bales and is carefully unpacked. The leaves, though dry and brittle, are rehydrated using steam or mist, just enough to restore pliability without making them too wet. Next comes cutting. Using rotary blades or precision slicers, the leaves are shredded into narrow ribbons known as rag. But not all the tobacco in a cigarette comes from whole leaves. What happens to the stems, scraps, and dust? These byproducts are turned into reconstituted tobacco, ground into a pulp, flattened into sheets, dried, and shredded again. It's tobacco recycling on a massive scale. Then come the additives. Why does every cigarette taste the same, regardless of where it's made? This consistency is achieved through humectants like glycerol to retain moisture and additives like cocoa or sugar to modify the smoke's harshness. this. Throughout, the tobacco's humidity, color, density, and even chemical composition are monitored using real-time sensors. Every blend is tailored to brand specifications, ensuring that what you smoke in New York matches what someone else lights up in Tokyo. Chapter 4. Making the filter. What about the filter? The little cylinder at the end that promises a cleaner smoke. What is it made from? It's not cotton, as many assume, but cellulose acetate, a type of plastic made from wood pulp. Inside massive machines, this material is stretched into tow, crimped, and treated with plasticizers to hold its shape. The result is a long rod of filter material wrapped in porous paper and cut into sections. These rods, known as filter plugs, are sliced into 3 individual filters in one pass. Their length, diameter, and firmness must match factory specifications within microns. Filters aren't just passive barriers. Some are ventilated with microscopic holes to dilute the smoke. Others include charcoal or flavor capsules. How do these tiny changes alter the smoker's experience? The filter's construction can influence burn rate, draw, and even perceived harshness. Chapter 5. Rolling and assembly. Now it's time for precision engineering to take over. Cigarette machines, some the size of small cars, operate at breathtaking speed. In 1 minute, a single machine can roll, cut, filter, and sort thousands of cigarettes. But how do they maintain such accuracy at high velocity? The shredded tobacco is deposited onto a moving paper web. As it travels along a conveyor, the paper wraps tightly around the tobacco, forming a continuous rod. Glue is applied via rollers, and the rod is compressed and sealed. A filter is attached using tipping paper, which also serves as the brand's visual identity. This paper must align perfectly every single time. Then the long cigarette rod is cut into uniform lengths using rotating blades. Sensors scan each cigarette, checking for weight, firmness, and density. What happens if something is slightly off? The machine ejects defective sticks instantly. The acceptable ones are guided into trays with robotic arms and air pressure systems, ensuring not a single cigarette is crushed or bent. Chapter 6. Packaging and wrapping. What's the last step before shipping? Packaging, the silent salesman of the tobacco industry. Groups of 20 cigarettes are bundled together and wrapped in foil to preserve moisture and aroma. This inner wrap also serves as a barrier against contamination. The bundle is then placed into a pre-printed cardboard pack, often with branding, health warnings, and security markers. Each pack is shrink-wrapped in transparent plastic. This not only protects the product, but signals freshness and authenticity. Have you noticed the tier band around most packs? It's placed with millimeter precision to ensure easy opening without tearing the pack. Packs are grouped into cartons, cartons into master cases, and cases onto shipping pallets. Automated conveyors and scanners track each unit from the factory, floor to the loading dock. At this scale, time is money. A temporary machine breakdown could cost tens of thousands of dollars per hour in lost production. Every movement is synchronized, from robotic arms to barcode readers working together in a ballet of industrial automation. Chapter 7. Quality control and regulation. But how do manufacturers ensure consistency across millions of units? Where quality control comes in. Cigarettes are sampled and tested throughout production. Machines simulate smoking, measure puff count, analyze smoke constituents, and check filter performance. Even the ash's color and length are scrutinized. Each country has strict limits on nicotine, tar, and carbon monoxide. Labels must be accurate. Warnings must meet legal standards. In Europe, for example, 65% of the front and back of every pack must be covered by graphic health warnings. Elsewhere, flavored cigarettes may be banned entirely. How do global brands adapt to all these differences? They tweak formulas, packaging, and even filter designs to meet regional laws. Chapter 8. Distribution and global impact. Once the product is packaged, it enters global supply chains. Trucks, ships, and aircraft ferry cigarettes across continents. They appear in convenience stores, vending machines, and duty-free shops. In some cases, they're smuggled illegally across borders. The global tobacco trade is as complex and shadowed as any industry. But what about the consequences? According to the World Health Organization, tobacco use kills more than 8 million people every year. That's more than HIV, tuberculosis, and malaria combined. The environmental cost is staggering too. Deforestation for tobacco farming, industrial emissions from factories, and billions of non-biodegradable cigarette butts discarded annually. Can one small stick cause this much damage? Conclusion: from a tiny seed planted in a remote field to a tightly manufactured product placed in the hands of a smoker, Every cigarette is a marvel of engineering and logistics, but it's also a symbol of contradiction, a product perfected for efficiency, flavor, and satisfaction, yet deeply entwined with addiction, illness, and death. Behind the smoke lies a complex story of innovation, profit, and consequence. The question now is, knowing all this, what will you choose to do with your next puff?